Hello everyone, welcome to the ITRS Academy. Today we are going to discuss the topic that is your milk powder, or you can say that dry milk powder. Dry, dried milk powder. So in today's lecture, we are going to see that what is this dry milk powder means that the introduction part. Then after that, we are going to discuss the manufacturing process, manufacturing process means that how we prepare this dry milk powder. Then after that we are at the last we are going to see the microbial aspects of dried milk powder. Okay, so as a name suggested that milk powder or a dry milk powder, that means that we remove the water content from the milk, okay, that normally milk which come in our home, and increase their shelf life. Okay, increase their shelf life. We all know that the shelf life of the normal milk is what? It's around 2 to 3 days at refrigerated condition. It is very important. At refrigerated condition. Shelf life of the milk is around 2 to 3 days at a refrigerated condition. But the shelf life of this milk powder is around 6 to 12 months at a room temperature. Okay, that means that you can keep the dry milk powder in a at a room temperature, that at a normally room temperature. Okay, but you have to take one care that it will not gain the moisture. It will not gain the moisture. Otherwise, the lumps are formed, and this lumps will changes the properties of this dry milk powder. That's why it is very important that it should be kept in a airtight container. It should be kept in a airtight container. Okay, so this is the basic of about dry milk powder. So let's start today's lecture. What is this milk powder, how we prepare it, and what is the microbial aspects? All of these things that we are going to in today's lecture. So let's start the lecture. Dry milk powder. Dry milk powder are prepared by a whole milk, skim milk, butter, cream, and whey. So these all are the raw material for the preparation of the dry milk powder. Raw material for the preparation of the dried milk powder. Okay. Whole milk, skim milk, butter, cream, and whey. Okay. And the types of the milk powder, or you can say that the product that we get from the raw material is whole milk powder. Whole milk powder are manufactured by the whole milk. Skim milk powder, it is prepared by a skim milk, and a buttermilk powder are prepared by a butter. Okay, and the moisture content of the whole milk is around 4%. Okay, whole milk powder contain a moisture content around 4%, but the whole milk have a moisture content around 80 to 85%. See, the moisture content is reduces from 80 to 85% to the 4%. That's why the shelf life is increases, and it will reaches around 6 months to 1 year, 2 years. Okay, skim milk powder have a moisture content around 5%, and the buttermilk powder have a moisture content or a water content around 4%. Okay, and the shelf life is around 6 months to 2 years. Now come to the next slide. Technology is step of milk powder. Okay, so first of all, we have to select and selection and preparation of the milk. Color and flavor abnormalities, spore and thermodynamic bacteria, um, clarification by centrifugal separator and milk sterilization. Fat content is around whole milk not less than 25% and skim milk not less than 1.5%. Okay, so when we are going to prepare this milk powder, first of all we have to select a milk and then prepare a milk. So the first thing that we have to keep in mind is that the color and flavor abnormality, when it is converted into, then maybe there is a color and flavor abnormality take place. Spore and thermodynamic bacteria are there, and the clarification are done by a centrifugal separator, and the fat content at that type of the milk is around, if it is a whole milk, then it should not less than 25%. But if it is a skim milk, then it should not more than 1.5%. We all know that skim milk is what? Skim milk is either no fat content or very less, that is around only 0.5%. Then after that, the next step is your clarified standardized milk at 4 degrees Celsius. Then after that, the milk that we get is clarified and standardized. Now casein stabilization take place, then preheating, then the concentration under a vacuum below a 70 degrees Celsius. Then after that, homogenization. Now preheated, homogenized and the stabilized milk are concentrated milk, it's go for a drying is done by either by a spray drying or either done by a roller drying. These two methods will be used for the drying of the milk. Then rapid cooling will be done, and then it is packed, and milk, we get a milk powder. From a milk we get a milk powder. So this is the normal procedure or the technology for the production of the milk powder. Now the next is your spray method. The first method for the production of dried milk is what? It is a spray method. Okay, here it is the like diagram for the, or sorry, apparator of the spray drying or spray method. The first one, it is here it is what? It is a air filter. Second is your air blower. This is your air filter. Okay, third is your hot air generator. Hot air generator. Okay, fourth is your material inlet hooper. Material inlet hooper. Okay, fifth is your screw feeder. Screw feeder. Sixth is your spray nozzle. This part is what? This part is your spray nozzle. Okay. Seventh is your spray chamber. This chamber is called as spray chamber. Eight is your product outlet. Here you get your product. Product outlet. Then ninth is your cyclone. This is your cyclone. Then eight is your rotatory air lock valve. This is what? This is your rotatory air lock valve. And 11th is your one ID fan. ID fan. And 12 is your chimney. This is your chimney. So this is a instrument of the spray drying. Now concentrated milk is sprayed through a nozzle under a high pressure or temperature into a fine particle to a hot chamber with the hot air dry. Okay, so when we get a concentrated milk, then it is spray with through the nozzle. Okay, through the nozzle and under a high pressure and high temperature, then it converted into a fine particle so that the hot chamber with a hot air dry current, that is around 160 to 250 degrees Celsius. Then it will be packed under a vacuum in a can and a uniform round regular particle with a diameter range from 5 to 10 micron. Now the next is this is your hot chamber. Okay, here concentrated milk are introduces here, and now here it is converted into a powdered milk. Here the hot chamber and the hot air current, that is around 160 to 125 degrees Celsius. Here it will convert it into a dry powder and moisture will remove, and it will convert it into a dry particle, and it is collected as a form of the as a form of the powder, and it will packed under a vacuum replace air inside it by a inert gas, either with the use of N2 or CO2, and particle size of the powder milk is around 5 to 10 micron. Now the next is your roller method. In a roller method, the concentrated milk will spread on a drum surfaces. Okay, so there is a drum surfaces like this. Now in a drum surfaces, the concentrated milk are spread, and it is spread in the form of thin film, and milk will dry within 6 to 30 seconds. Okay, so in a roller method, the milk are dry into a 6 to 30 second in the form of sheet, and it will remove by a special knife. Okay, so the powder that is formed is in the form of the sheet, and it will remove with the help of the knife, and this is the special type of knife. The product is usually passed through a brush shifter which break the product into a relatively small uniform powder prior to a packaging. Okay, now the powder is packed onto a 25 kilogram of sacks. Now the next is your vacuum roller method. This is same as the atmospheric roller method, but here the temperatures is around 255 to 65 degrees Celsius, and the product is of better solubility, higher nutritive value, and no change in the milk constitute. Okay, if we use a vacuum roller method, then we get a better mm, product whose solubility is better, whose nutritive value is better, and here no change in the milk constitute. Okay, so the nutritive value of this the product that we get from a roller method is unique. Unfortunately, it lost some vitamins like B1, B6 and B12, and even the vitamin C, and there is a loss of the some minerals. Okay, so uses of the milk powder. This milk powder are used in a preparation for the yogurt, manufacturing of the ice cream, infant baby food, chocolate industry. So that is the that's why the milk powder requirement of the milk powder is very high. Microbiology of the milk powder. Now raw milk is of great significance. It should be of good hygienic quality. Okay, we all know that raw milk are what? They are a perishable food. Okay, that's why they have a very high significance, and it should be controlled under a good hygienic quality, and they have a low count of thermoduric and spore former bacteria. So this preheating process is very important so that it avoid the contamination, and packaging process should be done under a strict hygienic condition. Okay, but here the microbiology of the spray dry milk. Here microorganism may gain access to a powder are thermoduric, micrococci, streptococcus, thermophilus, streptococcus ficus, aerobic spore, formal like bacillus subtilis, and the coliform. They can grow in a dry milk which we get from a spray drying. Okay, now the next is your microbiology of the roller dry powder. There is here the recovery of the dry product from the roller present the first post drying hazard. Contamination may occur due to the manual contact with the powder during the collection by hand scale by a staphylococcus aureus and salmonella. Okay, so these are the two microorganisms which we get into a which we transfer into a dry milk powder by a hand if we using the roller dry method. Okay, so the next one is, now the next topic is your effect of dry milk powder. So, if we have a unsaturated fatty acid in the presence of oxygen and copper at a high temperature, it converted into a peroxide, and then this peroxide converted into a ketone and aldehyde. If it is converted into a ketone, then it will give a oxidized flavor to the milk powder. Okay, and if it is converted into a tallow flavor, sorry, if the aldehydes are formed, then it give a tallow flavor to the milk powder. Okay, this is your first effect. Now the next is lecithin present into a dry milk powder, which which at high temperature it converted into a trimethylene and it give a fishy flavor. Okay, so at high temperature and high moisture, if we kept the milk at high temperature and high moisture content, then it will lose its solubility and stale flavor, deterioration of the casein, dark color spot or brown color spot are also formed, and it give a stale flavor. Now the next is your milk converted into a milk powder with a unpleasant flavor, that is called a off flavor. Okay, so milk fat at the present of the lipase, there is a microbial or physiological sources and converted into a hydrolytic flavor, and it give a rancid flavor. Instant milk powder. Okay, now the concept of this instant milk powder is what? Spray dried milk powder has a good solubility, but it deficient to be wetted, sink or disperse rapidly. Moreover, when added to a water, its proteins tend to form a sticky substances or form a lump. So its complete reconstitution is very difficult even with the agitation. Okay, so when we get a product by a spray dry method, then they have a good solubility, but it have a deficient to be weighted, and they will sink or disperse rapidly. Moreover, when we added a water, its proteins got sticky and lumps are formed, and the complete reconstitution are very difficult. Even when we do a agitation, but due to formation of the lumps, their complete reconstitution is very difficult. Now the next is your milk powder, better reconstitution properties of milk powder. It's what? Better reconstitution property, wettability, dispersibility and sinkability than a normal milk powder. Then instant milk powder, when added to a cold water, then they have a good wettability and short wetting time, good dispersibility, good sinkability, good solubility. Manufacturing of instant skim milk powder, how we prepare. So for that we required a wetting of the milk powder particle, then redrying by the use of hot air under a vacuum, so that it will evaporate the excess of moisture, as during a wetting moisture increases to a 6 to 12%. Then there is a undesirable cones which will remove, and it give a homogeneous size, and sudden cooling will be performed, and then it should be packed under a vacuum by the use of inert gas in a laminated polyethylene bag. Here you see that milk powder 5% water and low solubility. Now it is humidify and wetting algominate milk powder, and it converted into a re-drying at hot air at 25 degrees Celsius, 5% of water and 90% of solubility. Okay, now this is about the manufacturing of instant skim milk powder. Aim: accumulation of the milk particle which give a porous aggregate, and it will increase the intestinal air between the particles, so our reconstitution start. When air are replaced by a water at the time of the accumulate will sink. This is your agglomeration, spraying, moistening, solidifying, and finish agglomerates. Okay, so this is your before and this is your after diagram. You see that before this agglomeration, there is a lumps are formed, but when it is instant drying method are applied, then it will disperse into a water completely. Now the next is your manufacturing. Again, this is a manufacturing of the same whole milk powder that we already discussed. Lecithinization. Lecithinization is occurred due to the hydrophobic nature of the fat, which are agglomerate contain of fat will not reconstitute well unless water with a temperature 20 to 45 degrees Celsius, so that a whole milk particle coated with active or wetting substances are good emulsifier. Okay, this is your fat globule. They are hydrophobic in nature. They will agglomerate and non reconstitute in a condition. So this is your powder spray mixture of lecithin and butter at 60 degrees Celsius. Final lecithin is around 0.2 to 0.3% in a powder. Now lecithinization, which give more free fat surfaces so that it will obtain a higher degree of dispersion. Now the next is your reconstitution. The waiting time of instant skim milk powder is not more than 15 seconds. Factor which affected the solubility of that instant milk powder is a good wettability, ability to sink, good dispersibility, and good solubility. If we talk about the good wettability, then it totally depend upon the particle size, and the particle size should be around 130 to 135 micron, and the solubility is less than 30 second. Okay, if we have if we the second factor which affect the solubility is a ability to sink. So large particle has more time to sink. If we have a large particle, then obviously it take a more time to sink. Good dispersibility resemble normal milk without the lumps, without the sediment, without the floating on the surfaces. Good solubility, spray drying method give a 99% and roller method give a 95%. Baby milk powder, under a certain condition, women are unable to feed their baby, so that so that this baby milk powder are developed, are manufactured from a cow milk. Okay, so constitute which are present in a milk powder, that is your total protein. If we talk about the now here we compare a human milk, cow milk, and it depend on cow milk. So total protein contained in a human milk is around 1.5%, and in cow milk is around 3.3%. So whey is around 60%, and in cow milk it is around 20%. Casein in human milk is around 40%, and in cow milk is around 80%. Fat is around 3.3, and in cow milk it is around 3.5. Unsaturated fatty acid is around 50%, and in cow milk it is around 43%. Saturated fatty acid in human milk is around 48%, and in cow milk it is around 57%. Lactose around 7 in human milk, mineral around 0.21, and it will give energy around 62 kilocalorie. Or if we talk about the cow milk, then the lactose is around 4.7, minerals around 0.72, and it gives us 66 kilocalorie. Okay. Now the next is your production of homogenized baby milk from a cow milk. So we have a mixture of vegetable and butter oil, so that it will increase the fatty acid, correlation of the fatty acid, correlation of the lactose, adding a demineralized whey protein. We have to add a mixture of vitamin A, D, and C, and we have also add a demineralized whey or mineral mixture as a calcium, magnesium, iron, phosphorus, and we have to avoid the addition of the potassium, sodium, and this chlorine. Then whey protein should be added, and demineralized water should be added. Baby food should be contain not more than 50% of per gram and free from a pathogens. Definition of the recombined milk: if the milk which resemble fresh milk that are result from an addition of the water to a skim milk powder with the addition of the AMF, which reach to the desirable fat content according to the legal standard in the presence of suitable emulsifier, then it is called a recombined milk. Recombined milk simply means that the skim milk powder plus water plus AMF. Okay, so requirement for the well balanced recombined milk, that is the water, it should be a good quality, free from heavy metals, impurities, not a hard water. AMF, cream or butter pure than 99.8% of fat, no need of refrigerated store, and skim milk powder. So this is all about the dry milk powder, their manufacturing and their microbiological aspects. I hope you will understand, but if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or if you have any query, you can ask your query to the helpline number that are already mentioned in your slide. That is 7080833450. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.